name is Kai Ricky. I'm a data engineer at Skillshare, just here in New York City. I'm going to talk about Kubernetes-native workflows with Argo. Just a quick agenda, just giving some context about what we're trying to do at Skillshare and the problem we're trying to solve. Go into a little bit about tool selection and some alternatives we looked at, and then finally talk about Argo itself or some details about it and our experiences using it. All right, so at Skillshare, we have a pretty small data team. There's 3 data scientists, 1 data engineer. That's me. We are hiring, by the way. And we're in a larger online learning startup, so Skillshare is a community of learners and teachers on creative topics, so stuff like drawing, photography, design. If at the end of this 2 days you feel like you need a break from data stuff and you want to do something creative, I encourage you to check it out. So we have like pretty small data right now, just in the tens of terabytes, but we have like a few different use cases. So did many data teams at small startups, we're doing multiple things. So data analytics is a big one, looking at like user behavior, setting up dashboards, analyzing experiments. We're also doing some ML, so we have a recommender and have many ideas for more models for things like content evaluation and community stuff. So, and then finally, we do have to do some integration. So just like moving data to different business tools like Blueshift for email marketing, Zendesk. I mean, this is typically not something that you would associate with a data science team, but usually at small startups like ours, we're the ones who end up doing it. So. I joined Skillshare earlier this year, and when I joined, we had some like standalone infrastructure pieces. Like we had a data warehouse that was getting some data into it somewhat infrequently. We had a lot of scripts being run on laptops. We had that one server that you SSH into and run your scripts. And so what we really needed was like a place to run all of these different like ETL tasks, so extracting data, loading it in different places, transforming it, doing like model training, running our integrations between tools, and we also needed something to orchestrate all of those tasks into workflows. So just to give you an example of the kind of stuff that we're doing, I mean, this is a little bit contrived because we probably won't be running all of this off of a single workflow, but it's just sort of giving you a flavor for the type of tasks that we're doing. So, extracting data from different places, transforming it, maybe training a recommender, rerunning some experiment analysis, and like pushing some user analytics to our marketing tool, right? So, this is how not to do tool selection. I think the best way to do tool selection is just to find a couple of guiding principles and then evaluate tools like through that lens. So our first guiding principle was operability. And so I have here, can less than one person or more than one person operate it? So what I mean by less than one person is one person not working on it full time. I have a theory that if you have like one smart person doing a heroic effort, like they can basically make anything continue to run, but then if they're not working on it full time, it may fall apart. And then also if more than one person needs to work on something and you can't coordinate that, then you're also not in a great place. So like the things that we were looking for were basically like low conceptual complexity. So we were okay with sort of technical complexity, but we wanted to kind of minimize the total number of moving parts so that people could actually like reason about the system in a way without having to like look at a giant Confluence doc that's like, here are the 18 different parts of our data platform. And sane deployment and development of workflows was really important to us. So I think this is like a pretty underrated component of just data tools in general. It's like, hey, can I actually deploy it on my local, can I develop it on my local machine and run it in a similar way that it's going to run in production? Can I do a deployment without stuff breaking? And then just little things like logs, metrics, secrets management, these are all sort of stuff that I think people kind of think of as nice to have or like after the fact stuff, but we wanted to really make sure that we had all of that in place from the start. And then our second guiding principle is just reliability. So do workflows run how they're supposed to run? So for that, you need like explicit dependencies between steps. You don't want to have anything that's just assuming something else has run. And also, we kind of wanted to avoid doing too much like polling or using like webhooks and things. We wanted to have a workflow system where like one thing directly led into another. It's important to us to decouple our execution logic and our orchestration logic. So sometimes when people are using stuff like Airflow or Luigi, depending on how they're using it, but you can sort of couple like what's supposed to run with when it's supposed to run, and we wanted to just have those things be completely separate. So for each of the tasks, what it's actually doing should be like sort of irrelevant from like what's triggering it, whether it's in a workflow system or some other workflow system, or we're just like running a step manually. So which we don't want to do, but. And then finally, like we wanted something that could scale through like pretty big data volume increase, and this is just kind of something that's we're starting from a small point, but we are a growth stage startup. Our customer base is growing pretty quickly year over year, and then also we just have a lot more instrumentation. Once you start giving people data tools, they want to use them, and they want to like put more data into the system, and then more users meaning more internal users. So again, once you give people ways to build workflows and build pipelines, they're going to start doing that. Some things we didn't really care about right now, so graphical creation of DAGs. Didn't care so much about programmatically generated DAGs, and permissioning and security. Like at the stage where we're at right now, it's basically everyone on the data team has access to everything, so we didn't need a permissioning model. This is what we definitely didn't want. So if you're a data scientist, you've probably sent this message to someone, and if you're a data engineer, you've definitely gotten this Slack message from someone. So one of our first decisions was to build it or buy. So we looked at vendor tools. I mean, nothing that we're doing is particularly unique, right? Like doing ETL and even doing integrations between tools and is not like something that's specific to us. But we didn't find like any single vendor that did everything we wanted, and we kind of wanted to avoid like mixing and matching tools because it's really hard to do reliably. Like if you're doing your ETL in one place and you're doing your with one tool, you're doing your ML with another tool, and then you have some internal scripts that are running. Sort of orchestrating all of those can be really difficult because a lot of vendor tools like don't really have fully fledged APIs for doing things like notifying you when something is done, or even sometimes when something has failed, it's like you just get an email or something, and that's not really what you want. Also, development can be kind of tricky with vendor tools. Like, if some good tools will have like let you spin up a development environment and a sandbox environment, a production environment. Not all of them do, and then deploying changes across multiple tools at the same time can be really tricky. So, if you're using a managed tool for ETL, you have to make sure that and another managed tool for ML, or you're doing ML in-house, you have to make sure that those things changes to both of those are coordinated, and that can be tricky. And basically, for the stuff that we were doing, the kind of tasks that we were doing, the extraction, the transformation, we felt pretty comfortable using open source tools, or in some case, just writing code for them. And some of the pieces were already written, so our recommendation system was like already written out and containerized. So since we decided, okay, we're gonna do some of this stuff, we're gonna run this stuff on our own platform. We definitely wanted to use containers. I don't think there's any reason to just be like running code outside of a container in 2019 in a production environment. And so we built containers for a small set of initial tasks. Needed a place to run them. Our SRE team hooked us up with a Kubernetes cluster, so they helped us provision it, and they're helping us sort of co-maintain it. That's a really big thing. I mean, I'm not going to understate the sort of maintenance effort and the difficulty of provisioning Kubernetes in the first place. So if you're having that already done for us was a huge help and something we want to take advantage of. And there's just lots of benefits with using Kubernetes if you are going to be running containers. Scaling is the big one, of course. But again, even small things like secrets management, it's really easy to have like parity between different environments because the whole environment is just a set of piece of code, and you can run Kubernetes. Like we all have Kubernetes just running locally on our laptops and with the same sort of configuration as Q in production, just with different environment variables. And it also has good integration with Datadog, which is useful. So. All right, so we were like, okay, we're going to use containers, we're going to use Kubernetes, how are we going to orchestrate it? So our first thought was to use Airflow, but we weren't enthusiastic about it for a few reasons. So, I mean, Airflow is like pretty complex. There's a lot of moving parts. There's the UI, the scheduler, the executors. You can have message buses, and it's kind of full of, at least in my experience, like it's full of foot guns, meaning ways that you can just, if you're not using it correctly, you can shoot yourself in the foot. And we're not going to be using most of the features, right? If we're just using a single executor, we're not going to be taking advantage of the sort of UI components that, we're not going to be taking advantage of the permissioning. Like, we wanted something that was simpler. So that's where Argo comes in. So what is Argo? So it's an open source Kubernetes workflow engine. It's built by Intuit of TurboTax fame or infamy, as the case may be, but it has a lot of contributors outside of Intuit, and it's pretty active. There's new releases like every couple of months. So Argo is actually a set of projects. There's two that we were interested in: Argo Workflows, which is the way to define and run workflows, and then Argo Events, which is just a sort of flexible event system for Kubernetes that we use to trigger workflows. Argo also has components for doing like CI/CD, but that wasn't really relevant to our use case. So what does Kubernetes-Native mean? So workflows and events are defined as custom resource definitions in Kubernetes, meaning that they're basically sort of like native Kubernetes objects, and or Kubernetes resources, and they can interface very easily with other resources, so secrets, config maps, volume mounts, and workflows take full advantage of the Kubernetes scheduling, so you can do like affinity, taints and tolerations, set resource limits. So here's an example of what an Argo workflow looks like. So first thing you'll notice is that it's defined in YAML, just like in every other Kubernetes resource. That, depending on how you feel, that can either be like a positive thing or a negative thing. For me, I think it's pretty positive because basically means that the workflow is declarative. There's no sort of execution of, or like imperative execution of steps in the same way that you would have with like a DAG that was written in Python. So the workflow steps are just container images, and you can basically just declaratively define a DAG. So in this case, we have like 2 extractions and then a transformation, and we just define the dependency between, so the transformation is dependent on the extraction steps, and when you execute it, it'll run the extraction steps first and then run the transformation, which is pretty nifty. So there's a couple of ways to run a workflow. Like for development, you can just there's a command line tool called Argo, which is just a wrapper around kubectl. So these workflows, again, since they are just Kubernetes resources, you can use kubectl to create them and tear them down if you want. But Argo has a nice CLI tool. So you can, you can submit a workflow. It'll run. This is the sort of just very small example from earlier. Gives you some nice output. As you can see, there's a pod name for each step of the workflow. So each workflow step, each of those containers is being scheduled into a pod. So there's complete isolation between them. And also, if you can use any of your existing Kubernetes logging, monitoring, whatever you're using, to just get the output of each of these steps. There's some advanced features. So there's parameter passing. So you can pass parameters from the command line. You can pass parameters between different tasks. So like the output of one task can be a parameter into another task. There's artifacts. So you can output an artifact from one step. And so this path here is like the place in the container after it finishes running where you want to pull the artifact from, and then you can kind of reference that in another as an input to another task, and be under the hood. You can hook it up to an artifact store, so either Minio or S3, and it just kind of seamlessly handles that. So that's really nice. I think we're not using this feature so much right now, but I think it's a pretty nice feature, and certainly like because Argo was originally or sort of oriented towards CI/CD. I mean, this is something that came out of that world, but we find it pretty useful, for data workflows as well. So there's just a couple of, I'm just going to go through like some miscellaneous features that we really like. So there's memoized resubmit, meaning that if your workflow fails, you can resubmit it and not rerun any of the existing steps just pretty easily. You can suspend and resume workflows. So if you have something that's taking a really long time, you want to just pause it, especially like on your local machine, you can just suspend it and then resume it later. And then you can also suspend workflows within the task definitions. So kind of like having a like press enter to continue or something, and that can be helpful in some cases. Like for example, if there's some incomplete data or some validation that needs to be done before, like if you need to validate something before you want to continue along with it, you can just add a suspend step inside the task. Let's see. There's many other features. There's sidecars and daemon containers. So sidecars are basically companion containers to each of the workflow steps. So if you have, you don't need to have just a single container per workflow step. I mean, it's just for simplicity. I think it's pretty useful to do that, but you don't need to. And a daemon container is pretty cool. It basically means that throughout the entire life cycle of the workflow, you have a container running. So you can use this for like if you want to have a database, for example, that all of your workflow steps are accessing, you can just spin that up in a daemon container and like have your individual tasks write into that database and then do some aggregation at the end. So this is, if you're doing sort of more map reduce type stuff without, or just something that needs like dedicated infrastructure to run, you can use a daemon container. There's all sorts of DAG shenanigans like conditional tasks, sub-DAGs, generated DAGs, loops, recursive DAGs. We generally try and stay away from stuff like this because, again, if we're going for operability and reliability, I mean, I think as your DAGs kind of get more complicated and start including logic and dynamic generation, that can definitely like create some problems for you. But if you need to do that kind of stuff, you can. There's also like you can do like partial DAG runs in a similar way that you would do with Airflow. Post-run hooks, pretty straightforward. After a step runs or after the whole workflow runs, you can do stuff like send a Slack message or update something else. You can also create Kubernetes resources as a task. I think for the data use case, I haven't figured out where this would be useful, but I'm sure some creative people in the audience can think of a use for this. So yeah, you can, for like as a task, you can spin up a pod or create a config map or something. There is a UI. It's pretty primitive. Any astute audience members will notice that this is not the same DAG that I showed before as an example, but it's just a screenshot from the internet. We don't really use the UI that much. I mean, basically, all it does is show you the what ran, and if you click into any of these boxes, it'll just show you the logs for that step. We find it easier to just use the CLI tool, but the Argo is working. The Argo project is working on the UI. They're definitely planning on adding features like kicking. Right now, I don't think you can even like kick off a workflow from the UI. So if you do want something with the UI, I don't think this is the right project for you yet. Maybe in the future. All right, so I'm going to talk a little bit about triggering. So the examples I showed earlier were like running workflows just from the command line. Obviously, you don't want to do that in production. You want to have a programmatic way to trigger your events. So this is where Argo events comes in. It's actually not part of Argo workflows. It's like a companion project. So you can use Argo workflows without any of this event triggering stuff, and you can either use the command line tool. There's also a web API, I think, that's built into Argo workflows. So if you want to just hook this stuff up to your, if you have an existing system that you're using to trigger stuff, you can. But if you want to use Argo events, it's pretty flexible. There's lots of different ways to trigger things, like pulling a Git repository, webhooks, schedule. That's what we use right now to just hit the top of our DAGs. But lots of different options, and there's also sort of, you can use some pretty sophisticated logic. So like this, let me see where the pointer thing is. Yeah. So these things are basically sensors that will listen to events, and you can define sensors to listen to multiple events at once. So you could have something that's like checking on a schedule and triggered by some other thing, and you can combine the logic either using like just ands and ors just to set up some pretty sophisticated triggering. And these little octopus dudes down here are, let me go back. These are your actual workflows. So I'm not going to give code examples of that right now because it's not that interesting, I don't think, but the capability is there. So one thing I wanted to touch on is packaging and deployment. So that was kind of one of the things about that we wanted in terms of operability. So because I think this is really cool, because workflows and events are Kubernetes resources, we can just use Helm to deploy and upgrade workflows, which is like really nice. So we package up all, like for every workflow that we have an individual package for it. So the source again is just like YAML files in GitHub, and then we can also in that same repository define it as a Helm package. So that means that like if we wanted to, let's say, deploy something to QA, we can just use Helm to upgrade the existing workflows. And one nice thing is that it'll actually, like if workflows are already in progress, it'll just continue to run them under the old version. So you don't have to like worry too much about when you upgrade stuff. Like with Airflow, if you're upgrading DAGs, sometimes like the new DAG will be running when you think the old DAG is running, or vice versa. Helm does like a pretty nice job of just not upgrading things until the workflow is done. Actually, I mean, that's not a Helm feature. That's just something that Argo does. But this also makes like dev and QA and prod deployments very seamless, because let's say we wanted to test out this new version of this workflow in dev, we would just do like a Helm upgrade against our local dev clusters running on our laptop, rerun the workflow, see how it works, and same thing in a QA and prod environment. And this can also be useful if you're worried about interactions between workflows, because then you can, rather than just packaging up individual workflows, in our case, our workflows are like pretty separate, so we just package them up individually. But if you want to have like a big set of workflows, you can also package those up together and then like deploy that to a QA environment and see if there's any like hidden interactions between like your new version of one workflow with another workflow that's in the same package. So yeah, I think that's a really cool feature. It makes my life very easy, because if I need to deploy something, it's literally just one line. So I'll just talk about our implementation experience. So it took us like about a week of, I think, full-time engineering work to set up Argo. It's not like a just completely out-of-the-box thing. I mean, you have to, most of the documentation for Argo workflows is like in the GitHub page itself. There's not a lot of like standalone documentation. Argo events actually has quite a bit of standalone documentation, but it's not an out-of-the-box solution. Also, just as a caveat, we already had Kubernetes set up. I mean, that's a pretty big thing. would sort of say to you, if you are not running Kubernetes at all, setting up Kubernetes and setting up Argo at the same time is maybe a little ambitious and something you should think about carefully. But if you already have Kubernetes set up, I mean, definitely like check out Argo. But the trade-off I think here is like it's more time upfront, but then the operational time has been cut down a lot. I mean, we've been running 2 production DAGs with around 20 tasks, so I mean, definitely not like a huge volume of DAGs, but these are things that run like every hour for the past 6 months, and I think we had like 1 production outage where one of our underlying nodes failed and a workflow hung, which is in theory something Kubernetes should be able to handle and self-heal from, but it didn't in this case. But that was just fixed by like a pretty simple restart. And use Datadog for log aggregation. Again, it's really useful to have the output of all of your workflows in a single place, and you can set up filters just so, like if you're doing proper logging where you're using like log levels and stuff. Like we just have an alert that if there's an error in any of the workflow logs, that we'll get notified. And so there's a couple of things that Argo can't do right now that we wish it could do. So the big one is like you can't limit like top level DAG concurrency, meaning for a given DAG you can't say only one of this DAG should run at a time. That can be an issue with like time-triggered workflows, right? So if you have something that's running every hour and for some reason it takes 2 hours to run, you will get a second copy of it at the end of the next hour. That could be, I mean, that could be a deal breaker. That's something that we've worked around for now. You can definitely adjust concurrency within the workflow itself. So there's task concurrency, but at a global level, there's no way to limit like DAG concurrency. And then, like I mentioned earlier, Argo events is a little complex. There's a few different objects involved. There's the events, the gateways, and the sensors. We kind of toughed it out and set it up, but you can just trigger the workflows through an API if you want. That may be easier for some people. Does anyone have any questions? And before that, let me just give a quick plug. So we're hiring 2 data scientists, 1 analytics focused, 1 ML focused, and a data engineer. So if you're interested in working with some of this stuff, please come see me after the talk. But otherwise, that's it.
Hey, if I wanted to do some sorts of canary testings between 2 models, is that possible to implement in Argo as well? Canary or A/B testing, any sorts of?
Well, so let's see. I mean, you could implement it in Argo, but basically it doesn't have any like built-in feature to do that. You would basically have to like run 2 models in a workflow and then have some sort of like post-run step that sends the output somewhere and you can compare them. But really, it's just like a way of sort of running containers in a certain order.
What you mentioned earlier with the being able to spin up the pod, separate pods, and then have them spin down based on specifying each test, that would be probably more useful, right?
Yeah, right. So you can, so you could, so by default, pods will just end like when the task ends, but you can also you can sort of exit pods early if you want within the task itself, if you wanted to do that. I'm not sure if that's your question.
Yeah, well, and then are there resource cleaning when?
Yeah. So it's there's garbage collection of resources. You're right. So so we actually we let our pods sit around for a little bit because we want to have them in case we want to go back and just see what happened in more detail. But you can just set stuff to just go away as soon as the workflow ends.
And then one last question is, are there any metrics alerting besides Datadog?
Yeah, I mean, so Argo doesn't have any built-in metric stuff itself. So yeah, you need to bring that yourself. So yeah, we use Datadog both at the cluster level and then within individual tasks. So.
Hi. So first of all, thanks for the talk.
Yeah.
So I had 2 questions.
Sure.
So I'm an avid Airflow user, so that's a disclaimer, so you know where I'm coming from. So firstly, can you backfill DAG runs using Argo?
There's no, yeah, it's that functionality is definitely not as baked out as an Airflow. I mean, you would basically, you can sort of, you'd have to do it yourself by like parameterizing your DAG run, and you can pass in like a start date and end date. But yeah, it doesn't really have any built-in notion of like time in the same way that Airflow does. Yeah.
Okay, fair enough. And the other one is, how do you test your DAGs? Because it's YAML now, so Airflow DAGs are Python, so they're easy to test in a sense.
Yeah, so for testing, we kind of, we use like basically like a data validation approach where we'll use like data tests. So we'll look at what the output should be and then write tests against that. We don't actually test the DAG logic itself. I mean, most of our DAGs are pretty simple, and we're more interested in like the output than anything else. So it's kind of like integration tests versus unit tests.